Hello, good morning, guys. Welcome to the daily coding workout. Today we are solving this problem, lowest common ancestor in a BST. Lowest common ancestor in a binary search tree. Okay, this is a full form, binary search tree, and this is a lowest common ancestor. Okay, now what an LCA? In a BST, the lowest common ancestor of two nodes is the lowest node in the tree. Here they give us one definition given a binary search tree with all unique value and two node n1 and n2. They give us one exact definition like n1 does not equal to n2. You may assume that both nodes exist in the tree. Find the LCA of the given two nodes in BST. LCA between two nodes N1 and N2 defined as the lowest node that has both N1 and N2 as descendants where we allow a node to be descent itself. Okay, so here we are considering a two node in tree. Okay, first n1 does not equal to n2. Now first of all they give us LCA of two nodes is the lowest node in the tree that has both given node as a descendants. This means that all paths from the root to those nodes must go through this ancestor. Okay, so we talk about real world application of this problem. First, hierarchical structure like family tree, organizational tree. Second, file system and version control system. Okay. Third example, let me consider network routing algorithm. Okay. So this is the three example of this question. Now I am going to explaining approach to solve this problem. Right subtree. Right right subtree has a one unique node. Left subtree has a unique node. Okay. So we are considering first of all root node value. Okay. What is the value of this root node? We are considering if the value is the root node is greater than this both node, then going to right subtree. If less than, then we going to left subtree. So this is our approach. Hmm, left subtree node contains values less than root. Okay, and same like right subtree nodes contain values greater than the root. Using this property, we can efficiently find the LCA without traversing the entire tree. Okay, now I am going to write a code for this question. First of all, writing the code and then explain you, or I can explain with writing around the code. Okay, so first of all, I am mentioning if condition. If not root, then it will be return root itself. Second thing, if root data greater than n1, means node 1 data, and root data greater than n2 data, then return ancestor root left side. It's go to left side n1 comma n2. If root, now we have to just changing in right side. Okay, so we copy here and paste here. I just need to change something here, like greater than to less than. If root data less than n1 data and root data less than n2 data, then it will be going to write n1 and n2. Then here return root. Okay, now I have to make one function here. It will be ancestral function. Sorry, we have forget to make one function here. Node ancestor and ancestor node star root comma node star n1 comma node star n2. Okay, so these all function work in this curly bracket. Now I am going to here close this function and make a function name as we need return ancestor function. Okay, in comma root n1 and 2. Let me run this code. Wow, our code is run successfully. I already tested this code before to explain you guys. To be honest, I already submitted my code. You can see here my submission. Uh, Now I am going, this is our coding part. Now break down the functionality step by step. Okay, so first of all we write if not root, then return root. In this case, if they are giving a single output as an input, so that time we have to use return as a root. Okay, if they give us a single input at that time. If tree is empty, we can say as a tree is empty, we can say as a root equal to null. So that means there is no LCA, so we have to return a null, you know. Okay, now I am going to I have to make this scrollable. Here in this if condition I write root data greater than n1 data as well as root data greater than n2 data, then return it will going to left part of the tree with n1 n2. Okay, so both n1 and n2 are smaller than root. It means left subtree. If greater than root, that it means right subtree. And last, return only value of the root. Okay, so let's start a dry run of this program. I am considering a value like 20, 10, 30, 5, 15. I can consider this value as 5, 4, 3, 6, 7, 8. 5, 4, 3, 6, 7, 8. Here they give us a 7 and 8 as a n2. This is n1. This is n2. And this is our root node. Root node value is 7 and 8 greater than 5, right? So we have to go to right part. Output will be, what will be the output? 5. No, output will be 7. This is our result. Okay. LCA is 7. What is the time complexity? Time and space complexity of this program. In each stop, we move left or right depending on the value of n1 and n2, right? So the worst case occur when the tree is shoot like a linked list. Okay, so it giving a big O of n time complexity. For a balanced sheet, for a balanced BST, then height will be big O of log n and time complexity will be big O of log n. Okay, so in a conclusion part, first point, LCA BST can be efficient found using BST property. Second point, time complexity is big O of log n for a balance sheet. Balance sheet नहीं, BST, balance binary search tree. Okay. And the third thing, uh, the recursive approach. Make it simple and efficient. Fourth thing is the approach is used in file system, hierarchical organization and network routing. Okay, so that's all for today. If you found this video helpful, make sure like, comment and subscribe for making more coding tutorials. See you next time. Okay, thank you guys.